Object I/O. Object streams read and write objects as their basic units. Data input streams and data output streams are used to write primitive data types to streams, as seen earlier. Similarly, object input streams and object output streams are used to read and write user objects to streams such as files, buffers, piped, and so on. Any object that is going to use I/O needs to implement serializable interface. That implies that object which is to be read or written to a stream must implement the serializable interface. Here are the object stream constructors. They take input stream and output stream as parameters, similar to data input and data output streams. The two important methods of object input stream and output stream are read object and write object. The read object returns an instance of an object class, and write object takes an object parameter and writes to the stream. Let's look at an example. In this example, I have created a file output stream and wrapped the file output stream in an object output stream, as you can see at line 10 and 11. At line 13, I am writing an array object to the object stream, which in turn would write it into a file stream, and then to the file test.dat. At line 18, I am creating an object of object input stream wrapping the file input stream, which further refers to the file test.dat, where we have stored the array object. And then I am reading the object input stream at line 19, which in turn reads the file test.dat. The method readObject returns the object, which in turn is casted to the array object, as you see at line 20. And further, we are printing the elements of the array. This example demonstrates you how you can persistize an array object to a file system. Now let's talk about the random access files. Random access files not only allow you to read and write the file, but also move to any point within the file. Because of this ability, it can be used to search and update files. A random access file object behaves like a large array of bytes. The random access file object acts as a pointer which indicates where in the file a read or write operation begins. Now let's look at the syntax to create a random access file object. You can create an object of random access file by passing the file object or also by passing the file name, as you see here in this slide. Here I am creating a file object and passing the same to the random access file. And here I am directly passing the file name. This signifies the mode of operation. RW means read and write. Let's look at a couple of examples. In this example, I am opening a file r.dat in a read-write mode, as you see at line 5. When I open the random access file in a read-write mode, the file pointer of the random access file object would point to the beginning of the file. At line 7 and 8, I am writing a double and integer value to the file r.dat. Here I am using the functions writeDouble and writeInt. Unlike the previous example where I was using a file output stream to write to a file and further a file input stream to read from a file, here I am using a random access file to both read and write to a file. As discussed at line 7 and 8, I am writing to a file. And further at line 10, I am moving the file cursor to the beginning of the file by using the seek method. Seek method takes the index position as an argument. 0 indicates beginning of a file. And at line 12, I am reading both double and integer value and also printing the same. Before reading, I am setting the pointer to 0th position to indicate the beginning of the file. You can also find this example in Java Virtual Guru. Serialization. Serialization involves saving the current state of an object to a stream and also restoring an equivalent object from a stream. Imagine a situation where you have to send a set of data or a record across the network. Or maybe you have an object which is not required immediately by your application, and it also occupies a lot of memory, and therefore you wanted to release the memory. In such a case, you cannot just make the object eligible for garbage collection. You would first need to save the state of the object. This is when serialization comes into picture. Objects are serialized by using object output streams, that is, sending the object to a stream. Objects are deserialized by using object input stream. That is, the objects are brought back into the application by using the object input stream. A transient variable cannot be serialized. If you can recollect, we have been talking about transient and volatile in Unit 1 of Java Virtual Guru. And I promise to once again talk about transient and volatile in Unit 7, that is Java IOs. As the statement says, transient variables cannot be serialized. That is, their values do not get persistized. If you have a situation where you have to declare a member whose value does not signify the state of the object, then it's a good idea to declare them as transient members. Every data member declared in a class is by default a volatile member. Volatile members are used to signify the state of an object. However, transient members may also be used to secure sensitive data which I would like to prevent from sending into a stream. Serialization is implemented using serializable interface. Serialization also includes subclasses of serialized classes. In order to make your class serializable, you need to implement the interface serializable interface. Steps involved in serialization. Make an object of the destination stream, such as buffered, piped, socket, and so on. For example, here I am using a file output stream. Then step 2. Make an object of object output stream which would wrap the destination stream. In this example, it is FOS, an object of file output stream. Step 3. Write the object you intend to serialize using the object output stream. OOS.writeObject. Step 4. Close the object output stream. The object is first sent to the object output stream, where it is further passed to the destination stream, that is file output stream, which is further sending it to the myfile.ser, that is the file. Let's look at an example. Here is a simple example to demonstrate serialization. In this example, I have a serialized class serialization demo, which includes two string data members. Transient string transstr is a transient member, and the other by default is a volatile member, and therefore I have not used the keyword volatile. You may use the keyword if you wish to. In class main, I have created an object of file output stream as a destination stream. Then I have an object output stream OOut which wraps the destination stream. Further, I have created an object of serialization demo SD. Then I have written the SD to object stream using the writeObject method. Let's compile and execute this program. Now let's check what is written into the serialization.txt file. Here is a serialized object written. If you notice, the value written only includes this is a volatile value. In this file, you would not be able to find the other message, that is, this is a transient value. This proves the transient values are not serialized.